Hello mechatronics students. In this video we're going to be talking about the metal lathe, and we're going to be making a spacer. So basically we're going to take a chunk of 1-inch steel rod, and our objective here is to make the spacer. We're pretty much going to leave the outside diameter the same, but we're just going to cut it to 1 inch in length and drill a 1/2 inch hole through the center. So it's going to be a 1 inch long by 1 inch diameter spacer with a 1/2 inch hole drilled through the center, and we'll demonstrate how we can go ahead and create that part. So here's the lathe, and one of the first things that we're going to need to do is to chuck up our stock. So it's always a good idea to power things down when we're trying to work on things manually, and we're just going to insert this through the chuck, and we've got a bunch of it sticking out the tailstock, or the on the other side, which is just fine. So we're using a 3-jaw chuck, and in this case I need to have about 1 inch sticking out at least, and then a little bit more room to work. So I've got about 2.5 inches that's protruding from here, and got to get it in the center too. That would help. All right. There we go. Got about 2.5 inches. The less material that sticks out, the more rigid the lathe will hold things and won't vibrate or chatter. So that's a good thing. So that looks fantastic. So our material has been stocked up. Sometimes you can get a little bit tighter on these if you were to go through each one of the holes, but for the most part we're in good shape. So the next thing we got to do is to figure out what is the cutting speeds, RPMs, that we're going to be using. So I'm going to jump over here, and on the lathe you'll be able to find a sheet, and that's going to have some information, a little formula. Just says the RPMs, the spindle speed, is equal to the surface feet per minute times 4 divided by the diameter of our cutter. So we're going to look up in this table and say, okay, what is our material here? We're going to do a rough cut finish here, and we're looking for mild steel, which has a surface feet per minute of 100. All right, so we're going to take that information. We know the diameter of the material is 1 inch. So 100 times 4 be 400 divided by the diameter of 1. So we're looking for a spindle speed of about 400 RPM. Now, if we go over here to the dials to set up our speed, the one that's closest to 400 RPM is 460, so we're just going to go ahead and set that up. This only has 8 speeds to choose from. So we're going to go ahead and set it up on high speed, and again, when you do that, you may have to turn it to get it to lock in, and then there we go. We've got it set up, so 460 RPMs on high speed, and we can lock this down and get ready to cut. So the first operation that we're going to do is called facing, where we take our tool and we're just going to clean up the edge of the material here to get a nice cut on it. So let's take a look at a different camera angle. Now for this particular job I have this style of cutter in here, and this is going to allow us to come in across the face, and that's really what we're doing here. It's called a facing operation, just to clean up the edge, that front leading edge of the material. So I put it in our tool post holder, and things get moved around and adjusted here, so we got to check some things out. We're looking to see that this cutter is right about in the center. I actually don't like my camera angle back there because of this tool post thing. I wonder if I can change that up. Let me see if I can get a little bit better. No, she wants to be there, and when it's over there I can't do anything with it. Well, I guess we'll have to deal with that camera shot. But we can see what's happening anyway. So we're all set here. It would be good, since we're cutting steel, to use some cutting fluid. In this case, we're going to use some of this Tap Magic cutting fluid, just kind of get a bit of that on the end of the shaft here, and that'll help with chip removal in the cutting process. So what we're going to do is get the machine kind of lined up so that it's almost touching that surface. We're good. And we always have to be careful about the chuck. You can crash the carriage and tool posts. You can crash all that stuff into the rotating chuck. That's always bad. So we want to be mindful of where our tool is relative to this. And if you were to crash it, we can really destroy some things here. So always avoid getting and making sure you're conscious of where your tool, everything that's moving in and out, so that it doesn't crash into the chuck. Okay, let's get this facing operation done. So we've got to turn our machine on. We are wearing safety glasses, and the guard is in front. You know, we folded the guard down in front, and we're just going to be running our cross slide in and out to clean up the surface, and we'll adjust our carriage slide a little bit as we need to advance the whole carriage into the part. Let's get her done. So there's our 460 RPMs, and we're just coming across here and cleaning up the face of this part. Just taking nice small cuts. Okay, so there our part has been faced. It's a nice clean surface on there. Very happy with that. Our next step is going to be to do some drilling. So we said we needed to drill a 1/2 inch hole in our spacer. So to do that, we're going to go ahead and chuck up a center drill inside of the lathe, or the tailstock. So we'll bring our tailstock forward here, and I've got this cranked out quite a bit, so we're going to back it off. And the drill chuck is already there. We're using our center drill bit, and then after the center drill, we're going to go ahead and use a regular 1/2 inch drill bit. So this center drill is short and stubby, and it's going to be held rigidly, and we'll find the exact center of our part. A drill bit sticks out quite a ways, and when it's trying to find the center of the part, it can do a little bit of wobbling around. So we always tend to use a center drill first before we drill. Let's go ahead and lock that in. All right, so we chucked up our center drill. And now we're going to back off our cross slide. Bring this in, lock down our tailstock. And the other slide, there's a handle behind here that we do not want locked because we're going to be feeding the tailstock in. And because we're cutting steel, use a little bit of the Tap Magic material cutting fluid. So we'll get this guy fired up, and we'll drill the end of that shaft. And let me see what that looks like on our other camera angle. It's a little tough to see right there. All right, I'm going to get you guys a better angle. Okay, so let's take a look at this angle, and we'll just back this off a little bit and show you what that looks like again. So we're just feeding the tailstock drill into the material. All right, we get a nice center drill location on that. Excellent. Very good. So at this point, we can go ahead and swap the center drill out for the 1/2 inch drill bit. Okay. Now, there are some markings on the tail stock that some increment markers right here. So what I've decided to do is to get it right up to a 1-inch line, and then I know that I'm going to feed it in about 1 1/8 once this starts to engage. So I'm going to push it right up against the material here and lock it in. Now we shouldn't be starting the machine up if this is in contact, so I'm just going to back it off a little bit, and by using the scale on the tailstock I can see that I'm feeding it in 1/2 inch at a time. And because again we're cutting steel, let's get some cutting fluid in place on the drill bit, and every once in a while I might have to throw some on the part itself. Alright, let's get her cut. Nice, beautiful chips coming off of there. Got a nice sharp drill bit. Okay, so I'm going to back off because I've got some, again, trying to keep it cool, keep our cutters nice and sharp. So I throw a little bit more cutting fluid inside the hole and on the drill bit, and we'll repeat. Okay, so right now I've got it in about 1 inch, but I said I wanted to go about 1 1/8 inches so that I knew I've got it all the way through. Alright, so now I'm pretty sure I've got the full depth that I need for my spacer. That looks good. So sometimes the tailstock can slip if we don't have it tightened down hard enough. So when that happens, your hole may not get as deep as we were hoping. So I'm going to just kind of eyeball this and see that we've got about that much material, and just a quick check on that to make sure that I've got the right depth in case the tailstock did slip a little bit on the bed. And yeah, it looks like I've got more than 1 inch in depth. So another way I could do that is just to take my caliper and slide it in there, check it out, and yeah, we've got about 1.2 inches of depth there. So it's deeper than it needs to be, which is perfect. So the last operation that we're going to do is parting. So we're going to change out on the quick change tool post from this cutter into our parting tool. Alright, so this is the parting tool. It's got a carbide tip to it, and it is really important that this parting tool is square to our stock, right? If this isn't square when we go to feed it in, we're going to break the parting tool. That's not good. So we want to ensure that the parting tool is square relative to the stock material. And how we can do that is to adjust this, loosen up this bolt here on the tool post. This is how we can change our angle. Okay? So it's like I said, very, very important that this is square relative to the stock so that we get it to work right. If it is not square, the parting tool will break. It'll make lots of noise, and this parting tool is not cheap. So let's make sure that it's good and square. And how we can do that is to grab a little square, something that we know is square, set it up there, and ensure that it's ready to go. Okay, so I've grabbed a small square and I place it against the stock, and then I can place it up against that parting tool, and this adjusts the angle of the tool post. We make sure that the parting tool is square. Then we can go ahead and lock down the tool post using the 1-inch wrench. All right, like I said, that is so important to make sure that the parting tool is always square relative to the stock, and we only feed in with the cross feed. This parting tool is not designed to be operated, it's only designed to go from the cross slide in. It is never designed to be utilized with the carriage moving in and out. All right, so I think we're ready to go. Parting, we use a lot of cutting fluid on the cutting operation. And in this case, we wanted to get it to a 1 inch as our distance that we're shooting for. So I'm going to adjust my camera angle a little bit more. Hopefully I can get in here and see this really nice. Okay. So how do we ensure that something is exactly 1 inch? Well, let's work on that. So in this case, what I found works really slick is to use the dial caliper and to use the end of the dial caliper so that we get it dialed to the correct length. So what I like to do is to get the parting tool right up close to the part, then stick the caliper in here and start with it a little bit longer, then just use the carriage to drive this so that the caliper stops right at that 1 inch mark. So it's hard to see all of that in here, but again, I started with this the end of the caliper a little bit further out, and I have this end against the parting tool, this end against the stock, and if I push the carriage, which is going to drive the parting tool, over, then I can kind of get it dialed in right at that 1 inch. So here it is again. The caliper is, the end is against the parting tool. The other end is up against the stock. And then if I drive this forward, drive the carriage forward until my caliper stops exactly at that 1 inch. There we go. Now I know that that's going to be at that 1 inch mark, and we can go ahead and make the parting cut. Excellent. So let's take this parting cut. I've got the guard is down, and let's go ahead and make that cut. So we're not going to touch the carriage slide, only the cross slide to make this parting. Get her fired up. This does take a bit of lube. So we've got some of that cutting fluid placed across there. And we're just going to feed the cross slide in nice and slow. And we're getting a good cut. And I always like to just... Alright, so I'm not happy with that. I'm getting quite a bit more chatter than I would like. And to help with that chatter, I'm going to slow down the machine. So instead of running at 460 RPMs, I'm going to change it over to 300 RPMs, and that should reduce some of that chatter that we're getting. If you hear that chatter, that's generally not a great sound. So again, we were shooting for 400 RPMs with this steel, and it was up to 460, so a little bit higher. You hear that chatter, reduce the speed, and let's try it again. There we go, the chatter went away. We're getting nice chips across there. Again, I always keep it nice and cool with the cutting fluid. I'm just dribbling it on. And we're just advancing the cross feed nice and slow. Letting that cutter do the work. Okay, so I'm getting close to the point where it's going to cut off. And one of the things a guy can do, takes some hands here, but we can catch it by using another tool. So we don't want to put our hands in there, but I'm going to put the cutting fluid in for the last time, then use a screwdriver in this case, or some sort of round object. Just going to get that in here. There it is, money. All right. So there is our 1-inch spacer. It might be a little bit hot to the touch here, and you can see the parting tool left a little bit behind. We could perhaps clean that up later, but let's check out our dimensions and see how it looks. We're aiming to have a 1-inch length on this. So here's the material. We're aiming for 1 inch, and actually ended up a little bit shy on there. So maybe some of that was some of the chatter, but we're about, 1.980, so about 20 thousandths shorter than what we're hoping for 1 inch. But we could obviously make another one pretty quick. So that's our basic operation. We could clean this up, deburr it, get rid of that extra piece, that ledge that's hanging out there, and away we go. That is making a 1-inch spacer. So in this video we went through facing operation, a drilling operation, and then we finished with a parting operation, and we got all the details there. So we also were able to adjust the spindle speeds, RPMs, for the type of material and the diameter of the material that we were cutting. So pretty happy with all that. We'll catch you next time.